Before we start talking about Virtual DOM, I want to see some hands of people who use Virtual DOM regularly, on a regular basis. Anyone? Okay, it's like half the... And anyone who has never used Virtual DOM here? Oh, very few. So, it's familiar territory then. Before I start about the Virtual DOM, let me introduce myself. My name is Johan Gorter. I work at AFAS Software as a software architect. What do we do at AFAS? Well, AFAS has a big ERP product, which means big in the sense of it has a lot of functionality in there. You can do customer relations, human resources, everything. Well, it's on the slide. We also have a workflow editor, intranet, extranet for customers. And we have 10,000 customers, which are organizations, and 1 million users, which are the employees of those organizations and external parties as well. We're 86% cloud-based nowadays. Everybody has been moving to the cloud in the recent years. And that's about how many cores and terabytes of data there is. So you can imagine this is a pretty big product, but it's also a bit of legacy there. We want to use newer technologies, but we have to do a lot of rewriting. It's huge, thousands of screens, millions of lines of code. And lucky for me, we are not going to rewrite all of that code. Instead of that, we want to do it once and forever. We want to put the business logic into a model and interpret that model and run a code generator over it, so it generates the code that we can execute, so we don't ever have to rewrite millions of lines of code again. And because we can use a code generator, we can do specific things for certain branches and certain customers. Well, we're very ambitious, but our deadline, luckily, is a bit in the future, which means that the decisions we're taking right now should be future-proof. Well, that means that we want to understand every bit of technology that we are using, so we're sure that in 2020 or something, we're still using the right thing and don't want to rewrite everything again. Okay, and that brings me to Virtual DOM, which is what I want to talk to you about. I want to talk to you about the 3 benefits that we've found out while using Virtual DOM. We've been using it for 2 years now. First of all, I want to show you that it's easy. Second of all, it's fast. And we're going to do the same profiling that we just saw. And thirdly, I want to show you that it's testable. Great, let's get started. About the easy part. If we look a little bit back in time, then we can see where we came from. Well, in 2006, jQuery came out, so that's how we wrote code. In 2010, MVVM frameworks made things a little bit easier for us with Knockout and Angular. And in 2013, something interesting happened. React was open sourced by Facebook. And the years to follow, there were many Virtual DOM frameworks created, including one by us, the Maquette framework. I'll show you why in a minute. Okay, so if I say writing Virtual DOM is easy, then we have to look back at how things were before there was Virtual DOM. I'll give you a quick look at this jQuery code. I hope you can still read it. All it does is the input, you can enter a name in there, and it greets you with hello and then your name. So it's not very rocket science. What can we learn about this code, how we wrote it back then? First of all, we have some duplication in here. The word hello is here twice, once in the code and once in the static HTML. And on the other hand, the logic that we write uses all of the UI as input and writes back to the UI as output, which means there's global state everywhere. And if the application gets more complex, well, there's a problem of creating a spaghetti code lying ahead if we're not curious. So, MVVM frameworks came out, in particular Angular. This is the newest Angular version. The same app again. Now we can write it a little better. Well, you can see the Angular code here. It uses a template and it uses a class. And a class with just a bit of state in there. This is cool, because now we can just write our business logic and all other stuff the normal way. We can just access a class, read its variables, the thing we're used to. So we're very enthusiastic about it. What I'm personally less enthusiastic about is the template string here. I'm not sure if you can see the backticks in there. The thing after template is just one big string. There's code highlighting there, but well, there's a new language to learn, and there's a new magic that happens behind the scenes. The ng model thing, the curly braces everywhere. You know, things that you need to understand, and also what they can do and what they can't do. So the binding magic is not so easy, if I may say so. So what do we fix in Virtual DOM? In Virtual DOM, you can express the user interface as a function of your state. That's probably the most important thing about Virtual DOM. You can just use a normal function. And here I used even a simple JavaScript function. You could also use JSX, for example, if you want to recognize the DOM nodes even better. But just to prove my point, I'm using the hyperscript notation here, and you can see me creating a div here, an input, type, all of the types there, and you just use, well, your name variable, I mean there's the variable in here, the normal way. And there's event handlers, so there's no magic anymore. You control what happens and what events are doing what to your application. But the essence here is you can express your whole user interface as one function. Well, that means you can debug your code. It means you can have static linting, you can find unused variables, unit testing, you can do code coverage, everything you, well, as a programmer know how to do already. So, I hope this concludes why I think it's easy. All we have to do is write one function that creates the whole user interface. It means the user interface is never out of sync with underlying data. Easy to test, debug, lint, easy to refactor. And let everything else be handled by the Virtual DOM library and the CPU on the customer's device. They make sure that the UI gets updated. They make sure that transitions are animated, and they are trying their best to get to you to 60 frames per second. That's not your concern. You just want to write the function and see the UI react to the state changes that you are making. So, I hope you agree with me that this is easy. So, at AFAS, we like this idea of the Virtual DOM, and we thought it was future-proof. So we wanted to pick a Virtual DOM framework. However, no framework had our holy grail. We wanted, first of all, to keep it simple, like the code that you just saw. But we also wanted the animated transitions, and no framework back in that time had the combination of both. So I looked at the frameworks that were already there, and well, it's like standing on shoulders of giants. You can see the code, you can see the DOM APIs they're using, they're fast. You can see the hyperscript notation that they're using. And I created, based upon that, our own framework, Maquette, and it's only just 1,000 lines of code, actually. So I made a website for it, and that's a lot more code than just the framework itself and the tests and all the documentation there. So let's have a look at MaquetteJS.org. Here's the website we created, and here you can see the code example. Well, it's the code we just saw. We can do hello Amsterdam.js here, and you can actually add more questions. Exclamation mark here. Well, you can edit the code. If you like, if you want to know this framework a little bit better, you can even play around with flying saucers. I can show you here that we can make flying saucers here, and the rest of the tutorial is up to you. Okay, let's present from here. This is our library. Back to the original program, I want to show you Virtual DOM is fast. So, how does Virtual DOM work exactly? DOM nodes are pretty heavy. You can change them. Changes are heavy. They're connected to the real DOM. Questioning them is, well, all heavy operations somehow. And instead of doing operations on the real DOM, we're making your function draw the DOM using virtual DOM nodes, which is the little house on top. So if you write the virtual DOM this way, then the virtual DOM library will create the real DOM in exactly the same manner. Well, let's imagine you press a button and a dormer appears. Then the virtual DOM library will ask you to will execute your function again, and we'll see note the difference. Well, there's one DOM node being added, the dormer, and then it adds it to the real DOM using an animation if you specified one, and that's how virtual DOM works. But wait a minute, I just told you I was going to show you that virtual DOM is very fast. Now this algorithm obviously is very inefficient. We are recreating all of the DOM again. We are looping over it, trying to find DOM nodes. Why is this so fast? Well, there are several reasons. First of all, creating the DOM is very lightweight. Diffing it is also a very minimal overhead. What you gain from it is that the real DOM is never queried. No query selectors are necessary. So that's very fast. And also the changes that are applied to the real DOM are very minimal. They're also applied in such a fashion that there's no reflows occurring. So this makes it actually very fast. So probably your best chance to get to 60 frames per second. Well, you might say, well, what if I want to go faster than 60 frames per second? Well, your device won't let you. 60 frames per second is what your device can handle and will handle. There's no need to go any faster than that. And it's not really strange that we can do 60 frames per second rendering and diffing. I mean, we've got games you play on our mobile phones which render 3D scenes and do a lot of logic behind the scenes at 60 frames per second. So why can't we just use a library to render and diff 1,000 DOM nodes? That's not shouldn't be a problem, right? Nowadays with software architecture. So it's not very strange. There are some pitfalls when why you wouldn't achieve 60 frames per second, or better say, why your user interface doesn't respond within a single frame. First one I put up there is React. React is the first virtual DOM implementation. It's a great invention, but it isn't the fastest one. And when you hear people about React, and you sometimes hear about the performance measurements they have to take, well, there are newer frameworks which are all claimed to be faster, and they're probably right. So if you experience problems, switch to a newer framework maybe. Don't make a DOM tree excessively large. On a mobile, more than 1,000 DOM nodes, or desktop 5,000, just arbitrary numbers, but keep those in mind. Your browser won't like it either if you have this many DOM nodes, so you shouldn't do it anyway. And make sure that your rendering functions are efficient. Don't parse any dates along the way, and don't do things like that. But then normally, in my experience, you get 60 frames per second, no problem. But don't take my word for it. I want to show you that it really does. So I've got a thing from our new application, Profit Next. I've created a big screen, as big as I could in this environment. The biggest screen I could find in this environment. I can create bigger screens, so you can see a lot of fields on here. Well, I think the sound is back online. Okay. So I want to show you some virtual DOM manipulations here. The first thing that we see here is a field, and when I type into it, it decomposes my name into my first name, last name, using the Dutch conventions. So if I type here, you can see a lot of things moving on the screen here and there. So let's show that it's fast and that the virtual DOM diffing doesn't hinder performance anyway. So let's do a recording like we just also saw. Let me type here and stop the recording. Just a moment. Well, we see here that here's where we did the typing. First of all, we see here that those frames only took 9 milliseconds. Well, we can zoom in a little bit, for example, on this screen. As you can see, I'm using the request animation frame there. So first of all, the key down and key up and key press and input events fired when I was typing. That took a little while. Afterwards, the animation frame callback came from the browser saying, hey, I'm ready for you. Please print your next frame. And then here's where the render method happens. So this function renders all of the 800 DOM nodes in only 2 milliseconds. And then we got to the diffing and updating is only just 1 millisecond. So we've got 3 milliseconds, well, which may be an overhead if we're using a different framework from maybe 2 milliseconds. So this means that we're sacrificing 2 milliseconds of our 16 milliseconds to ensure that the patches to the DOM are minimal and that we can achieve the utmost performance. Well, here's the thing that the browser needed to do, and you can see that it finishes on time. So here you can see a pretty big application running virtual DOM without performance hindering. So let's present from here. By now you've seen that, well, virtual DOM, if you're coding it, if you're making your functions, it makes you feel very inefficient. Well, just you write a function that you know will be hit many times, but still it's very fast. So it's a bit of a dilemma in your head, but it's on paper it's very fast actually. So let me switch to the third benefit. I hope you will agree with me. Using virtual DOM makes your code testable. What's the problem? When you write a user interface code, it's easy to break existing functionality because some of the functionality may be hidden, there may be edge cases that need to be taken care of. Well, we all know how to deal with them. We want to write unit tests, of course, and do code coverage to make sure that we didn't miss any spots. So we do this as AFAS, but we didn't choose the browser test. We don't want to test in a real browser because that's slow and that's flaky. So we came up with a solution, and there's a little framework we call MaquetteQuery. We named it after a framework we once used. What is it? It's a testing utility. It's used to query the virtual DOM. Well, normally the virtual DOM you only write to it and never forget it. But now we write queries for it in the query selector like API. And we run it in NodeJS. And NodeJS doesn't have a real DOM implementation, and we don't need to add one there. So let me show you how this looks. What's my time? Okay, lots of time. Here's the hello world. Is it readable from the back? Not hearing any complaints there. The hello world page that we just saw, it has your name in a state. The input handler here is all written in TypeScript, by the way. And the random Maquette function that we just saw. Well, we want to write tests for it. So here is our test setup. First of all, we don't use the real projector which projects to a real DOM, but we use a test projector which we use for testing. We create queries on it, so query for the input field, we can query for the output paragraph. And in our setup for every test, we want to create the hello world page that we just saw and initialize it. Now, well, we can write a test, well, it outputs hello you when no name has been entered. Well, all we do is here, output query.text content equals hello you. That's all we have to write. It greets the user by the name he's entered. Well, if you enter Amsterdam.js, for example, by dragging text into it and dropping it there, we expect the output to be hello Amsterdam.js with an exclamation mark. And it outputs the value being typed, while you can also do key presses here. And we can see the code running. Okay, you might say that's hello world. We believe hello world. Everything works in hello world. So let's try something a little bit more advanced, more production-like. So for that I made a little demonstration. I've got here a list of attendees, people walking into the session, if we may believe this data, which we shouldn't. 10 minutes, good. And we want to be able to filter this list to find a certain person here. So we can now find myself, but I'm not in here as well. So Joshua isn't in here as well. Well, but we can filter this list. So I think it's pretty basic what this component should do. A filtered list is something that takes the list and just filters using the keys given. Well, so we've got this component here, and it's as a create function. it creates this component, and it's configured with the getItems function, which retrieves the items. And what it renders is two other components, a text field and a list component. So we make it real production like that, we're reusing certain components. And here we render the filtered list with the form field and the list. Okay, let's have a look at these two components that we instantiate and render there. The list is the list that we configure with our getItems, and we filter it with a function here, and the function here matches the text that we've entered, and the text is also bound to the text field. So let's recap what's in here in this component. State, the text that is being filtered. We've got our sub-component, which, by the way, also lowercase the text that we enter here. So if I wanted to uppercase something here, it wouldn't work. It would do the lowercase. So in our rendering function, we render these things out. So we want to write tests for this one. Let's see if it works in a test case as it works in the browser. Okay, let's instantiate the filtered list here with the same projectors and queries. But we've got 4 fixed names in there. And let's see the first test. Well, it shows all of the 4 items when no filter text is given. Well, we expect this query to have 4 results. Well, it's all 4 in there. Also the test for lowercasing the text that we enter in the search field. We simulate input of a capital E, and then we assert that the output is the lowercase e. And a test for it only shows items that match the filter text. Well, that's the interesting thing, of course. We expect, when we input the letter J here, we expect only those 2 names to appear. Well, I can run this, and well, you wouldn't believe me, but those tests pass as well. So let's go back to the presentation then. But is it also fast, running your tests this way? Well, we've built quite a lot of code base here, and I've created a test suite here only for the UI components that use this framework, so I'm running it now. And you can see 1700 tests being run in 2.3 seconds. So this is no problem adding it into your build cycle every time. So let me now come to the conclusion. I've shown you that virtual DOM is easy, mainly because we can use a function that as a way to express how our DOM looks like. The notation for this function is different in any library, but in the essence, it's still a function. It's fast. We've seen the overhead being minimal and, well, being very efficient. And I've shown you how we test this code, and we're pretty confident that this works very well. So, if you want more information, my Twitter handle is there, the Maquette website that you just saw, we can create the UFO. If you want to know more about AFAS, we've got a developer's website, and the code that you just saw where I did the filtering is on GitHub under AFAS research, and then you can find it on the Maquette query demo. So I wonder if there's any questions left.